This, hello, everyone. Thank you for joining this webinar. My name is Gary. I'm one of the Hack3D competition coordinator. And today in this webinar for Hack3D, we just want to make sure that during the pandemic, with everything being remote and the competition, a lot of changes, we want to make sure that, want to keep the participants engaged. And so for today's webinar, we want to introduce the competition as well as introduce all of the organizers behind it and talk you through some of the competition and some of the research and the challenges behind that. So my name is Gary. I'm currently a PhD student here at NYU. So this is my first year. And in my research, I am focused on cybersecurity methods in additive manufacturing, 3D printing. And prior to joining the PhD program, I worked for a reseller of Stratasys and also SolidWorks for 5 years at a company called Trimec. And so my role as an application engineer is to support the software and the products of the company. So SolidWorks, if you're not familiar with, is a 3D design CAD program. And Stratasys is a maker of a lot of different 3D printers. I work mostly on the software of SolidWorks side. So in my experience, I have a lot of, my proficiency would be in CAD design, as well as supporting the SolidWorks software and using all the different suites of product that it offers. And prior to joining the research, in my experience, one thing that I've started to see across a lot of different companies is startup companies or well-known companies start to adapt to 3D printing for the prototyping, as well as even creating end-use part. But as I see more and more of them adapt to the 3D printing methods, also on the design side, you start to see some limitations that are present with, the features used in design might not be exactly for additive manufacturing or for 3D printing. And as well as in the manufacturing sector, you start to see that the security aspect of things is lacking in that aspect. So hopefully through overview of this competition and everything to promote that awareness of security in additive manufacturing field. So that's my background, and I'm currently working under Professor Nikhil Gupta, who is a professor from the Aerospace and Mechanical Engineering Department here at NYU Tandon. And he is the faculty lead of this Hack3D competition. And some of his research that he's doing right now focuses on advanced materials, new security printed methods for 3D printing, which is also part of my research, developing filaments for advanced composites, and using machine learning methods for material characterization. So he is the faculty lead, and you also see that joining me here on this webinar are a few other organizers. I'd like to introduce Hammond, who is our postdoctorate lead, and Caleb and Angela, who is also on the call, are our co-leads, and there are the undergraduates leads who participated in our summer research program, which I'll go through in a little bit as well. But I think here I want to kind of pass it off to Hammond, who will talk a little bit about himself and give everybody a brief introduction.
Thanks very much for that, Gary. So yeah, my name's Hammond. I very recently graduated with a PhD in computer systems engineering from the University of Auckland in New Zealand. My research was focused not so much in the security area, but definitely within industrial automation. where I was looking at guaranteeing the safety of industrial systems. So given some real-time industrial process, can we prove that that will meet its requirements? So examples might be fail safes, people detectors, circuit breakers, those kinds of things. In the last part of that research, I got involved with looking at that from a security standpoint. So if there are malicious actors trying to compromise your industrial systems, and that led me into a postdoc position here at NYU Center for Cybersecurity. So I've started working with Gary a little bit since I've been here. And I also work under Professor Nikhil Gupta and also Professor Ramesh Kuri, who is the co-director of the Center for Cybersecurity. Here, I'm looking at the cybersecurity risks within the actual implementations of additive manufacturing. So for instance, if you've got some kind of 3D printer that's going to be running software and firmware to process the instructions that you're giving it in order to print the parts that you want it to print, what are the capabilities if that firmware has some kind of virus or Trojan within it? Can we get it to print defects into those parts? Can we get it to print different parts? Can we get it to print counterfeit parts? So there's a whole load of different research avenues within that area, which is what I'm looking into, which also includes higher level cybersecurity things as well. So for instance, if there were to be a virus onto a 3D printer, how did that virus get there? What are the avenues, for instance, over-the-air updates, or is it coming compromised from the factory? So that leads us into more classical InfoSec problems as well. So I've been really enjoying helping out with the Hack3D competition. This is my first year working on it, and hopefully you guys enjoy the competition as much as I am. I think you're muted, Gary.
Yeah, thank you, Hammond. We also have here Caleb, who is one of our undergraduate leads, and he participated in our summer research program. So I'll let him introduce himself to everyone.
Thank you for that. So I'm Caleb Beckwith. I'm not actually from NYU, but I'm a senior of mechanical engineering of NYC College of Technology, so just down the road from Tandon. And I got involved with the summer research program, which allowed me to aid in co-designing your challenge for this competition. So my background is mechanical engineering, and thanks to that, I've been using 3D printers for about 2 years now. And so I was able to use my understanding of them and my expertise in that field to educate the other students on the workings of 3D printers and to better design this challenge to fit the mindset of someone that might have some experience with 3D printing.
Thank you, Caleb. And also, we also have Angela, who is also another undergraduate lead of this Hack3D competition, and she also participated in the summer research. Angela?
Okay, hi, my name is Angela. So I'm a sophomore at NYU in mechanical engineering. Basically, I didn't really know a lot about SolidWorks before I started, but throughout the summer, I was able to learn a lot. Like I watched a lot of videos, and Gary also helped me a lot with also, as well as my teammates that I worked with. So through that, we were able to work together and sort of help lead this competition.
Thank you, Angela. So with that, it's a brief introduction of the team and all the organizers behind it, and to moving on, talking a little bit more about the Hack3D competition. So the main purpose of the Hack3D competition is to promote awareness in cybersecurity in additive manufacturing field, which is a field of growing interest. And currently in the manufacturing sector, there is a lack of security or a limitation in if I'm an engineer and I'm a designer, what are some of the methods, some of the things that I can do to protect my design files? And right, because a lot of companies have right, intellectual properties that they'll like to protect and right, keep away from other people who might want to use it for some bad intent, things like that. So this competition, Hack3D, and the research that is behind it is interesting because it brings together two different fields of research, and it brings together, people of different backgrounds, people with, different fields of study, disciplines together. And for me personally, I am studying mechanical engineering, and I work with Hammond. So my proficiency is, designing, CAD design, and Hammer brings along, and we communicate ideas with each other. He has, computer science background and all the, computing, file forensic background. And we work together and brainstorm new ideas in this new growing field, which is the research behind cybersecurity in additive manufacturing. So this competition will test, your knowledge and skill across a lot of different topics. And from past competitions as well as the current challenge, you would find elements of reverse engineering, testing your design CAD skills, file forensics, deciphering and decoding certain things within the model or file. So there's a lot that kind of goes behind the creating the competition as well as the research. And every single year here at NYU Tandon, we host a summer research program. And in the summer research program, we invite undergraduates to come on campus into our labs to conduct research with, a graduate student as well as a leading faculty member. And in this year summer research program, due to the pandemic, unfortunately, it has to be remote, but we were still pretty productive in some of the things that we've done. And Caleb, Angela participated in the summer research program. And in that research, it was focused on creating security features for 3D printing, for additive manufacturing. And the question that we would like to address is, if I have design information that I would like to protect, how can I do that? So within, all of your digital manufacturing file formats, you have CAD, STL, G code. How can we design a security protocol, a method to be able to protect these files? So within the summer research program, there's a lot of different things that we looked at, right? And I don't know if Caleb or Angela want to share any of their experience, but most of them are from mechanical engineering background, or having that background, so they are comfortable with the engineering disciplines and designing in from a drawing or some of the other basic things. But in this research, it kind of expanded their knowledge in a way where you have to kind of think differently, right? Because designing for 3D printing or designing, for additive manufacturing is a completely different mindset. And when we have to look at designing security features, there's a lot of things that we can incorporate. It's not just looking at a drawing and creating a model from it, right? Can we incorporate some computer science disciplines into it, right? If I have a CAD file and I'm a designer, right, can I incorporate, different hidden messages, or how can I take the CAD model and protect it with some of these, computer science disciplines like cipher tags or plain text or any of that. So within the research, summer research, we've done a lot of different examples of things like that. I don't know if Caleb or Angela, is there
Yeah.
any particular experience? Yep, go ahead.
So we were sort of limited on time, so we were really only able to broach these sort of subjects, but the experience was still great, and we got to learn about different things like how we could devise a system to make a watermark in CAD that will show up throughout different stages of the design process, and what methods that we could use to make that more visible or less visible to our teammates down the line of the design process by sorry, I'm bad at speaking. By manipulating the facets of the STL, or just by adding extra parts to it, or even like what Gary was saying with the computer design aspect, we were able to take the code of the STL file and we were able to see, okay, this is how it's sort of laid out. This is the information that we can use, and this is the information that we can't really change without damaging it. So what information can we hide in here? And so that was really my favorite part of it, and just the different aspects of that I really enjoyed.
Thank you, Caleb. And just to kind of show an example or explore different ideas, I'll go ahead and share some of the things that we did during the summer research, and some of the ideas behind it, simply by talking about the warm-up challenges that we post in August prior to the registration opening. So there were 2 warm-up challenges that were posted, and it was worked on during the summer. And the first one is the basketball jigsaw puzzle. So the idea behind this, and the idea behind the research, when we have to brainstorm new ideas for security features, for 3D printing or for CAD, for design, right? When we're brainstorming these new ideas, in general, one thing that we have to do is keep an open mind and be really creative, and make sure that every idea that you have, you don't dismiss it because you think it's a bad idea, or you don't think it's going to work out, right? Every idea during the brainstorming process is good and should be tested and determine whether it's good or bad by then, and not dismissed early on when it's just a thought. So the idea behind here, when creating a security feature, and the creativity behind this, is, what if we take 2 completely different things that have no relation to each other and combine it together, right? In this case, and this idea came up because of the pandemic, and one of the hobbies that many people like myself probably picked up is jigsaw puzzles. So combining the idea of having a jigsaw puzzle with a CAD model and just combining it together to create this 3D jigsaw puzzle. And I looked at, are there any examples similar to this out there on the internet? I wasn't really able to find much. So this was pretty much a new idea out there, right? Having like a 3D jigsaw puzzle. So another thing is, this brings into the idea of, if I'm a designer and I've designed my part and I save it to my library, but every time I save it, there's a algorithm or software that takes my CAD model, breaks it up into all of these different pieces, maybe 100, maybe 1,000. Right? If someone were to steal my file, what is the likelihood of them putting it back together, be able to retrieve that design information? Right? So it could be, one possible idea for a security feature. And for this challenge, there really wasn't any trick or fast way to do it. It would just be, similar to if you have a physical jigsaw puzzle and piecing everything together, but everything is just done in the modeling realm. But one thing, there are things that can be done to help you with the jigsaw puzzle. So knowing that this is a basketball, one of the things that you know is, right, it's a spherical shape, as well as there's a certain standard diameter to the basketball. So what I can do is generate a spherical surface with the diameter of the basketball. The standard diameter of basketball is like 29.5 inches or something. And this gives me a good reference surface to kind of put all of my jigsaw pieces, right, onto this spherical surface. So that's exactly what I did. I just created a reference surface, and it'll make it easier to kind of right, place it onto this surface. And it's not just freely floating in space. It's right on the surface. So that's one little trick that could have been done to make it a little bit easier. You're not just kind of piecing it in random 3D coordinates. And then once you've captured that, it's just right joining the pieces and finding the right pieces together. So personally for me, I like to take the two vertex and join them together. So we have here. Okay. And then once you join the vertex, what I'd like to do is we can grab two edges and join them. Here, grab them, join them together. And then you're slowly piecing the basketball together. So that was the idea behind that, right? And it brings up the idea of right, if we were needing to right, protect our CAD information, right? Can this be a reliable method? So taking this, right? And in this case, the basketball is just a simple spherical shape. But if everybody look around there, where they are right now, if you right, find an object right, and you just imagine that it's broken up to many different pieces in CAD, right, can that be used as a security feature in the entire right, digital of the additive manufacturing process chain? So that brings in that idea. So with the jigsaw puzzle, right, it gets completed. Final results look like this. There are letterings on the basketball to aid in the jigsaw puzzle in Hack3D. The next challenge is the color challenge. And the idea behind this is, let's say that I want to send a message to Hammond. And for this message, I only want Hammond to be able to right, read what information is in it. And I don't really want anybody else to be able to know the information that I sent to Hammond. So perhaps I'll text him. And to protect that information, right, everybody has a, in their smartphone, they can apply a password protected code, or they can only access the phone, the text message with a fingerprint, right, accessing the smartphone. So the idea, right, kind of can be used to be incorporated into CAD as well, right? If I have sensitive design information, right, maybe I want to simply hide it from plain sight, right? If I open the model, I don't see it, maybe it doesn't come to my mind. So with the challenge here, the color code, there's 5 different colors, and maybe the first thing that you would try to do is try to find a pattern. But the idea here is if there is, secret information within the CAD file, and this is made public, right? Out of 100 people, how many can actually read the secret file? And this could be, another way of designing for security features in additive manufacturing. Because if we just simply take something and hide it from plain sight, it might not be visible and might not be so straightforward at first. But with a little bit of digging into the model, the trick here is to look at the back of the part and understand that within the part, if I just take a cross-sectional view and dive into just a little bit within the model, inside is actually hollow, and there is a secret message. Each letter from this message is color-coded, and the color depends on, right, how often does that letter appears in the message. So for example, letters that are shown in red appears only once. Letters shown in blue appears twice. So if you were able to come to the secret message, right, it will tell you, qualifying round starts September 15th. We can register at the site indicated. So this brings into the idea of these kind of deciphering, decoding, hiding from plain sight, right? Using these ideas to try to come up with a brand new, right, security method for additive manufacturing. So now that we know the pattern, we can simply, right, apply the color and get the actual code within it. So that is the color challenge warm up. Okay. And that's pretty much it. We have a few more minutes, and I want to talk about a little bit more about some of the things for the qualifying challenge. And some of you have, for the qualifying challenge, we allowed you to work in, right, teams of 3, 4, 5, doesn't really matter. If you are a team of 1, we are currently flexible. So if, today, tomorrow, later on this week, you want to add somebody to your team, feel free to do that. It can be up to teams of 3 or 4. So if you do want to add another team member because you're working alone on the challenge, feel free to send an email to the Seesaw email and just let us know, we'll update the information about your team. Another thing is for the qualifying challenge, we've asked that everybody submit a CAD file. Along with that CAD file is to submit a written document. And for that document, the Word document, try to be as detailed as possible and try to organize your ideas all into that documentation, listing all of your initial observations, what approaches that you take, right? Why did you take those approaches? So the organizers, when reading through your documentation, can have a clear understanding of, the thought process that went into it. So try to be as detailed as possible and list anything that comes to mind. The last thing is the submission will be October 16th. So even if you, right, have not fully completed the qualifying challenge, right, feel free to still submit your whatever you have, right, your written documentation, the CAD file, because think about it like this, right, out of a class of 100, if the average on the test is 65, you get a 68. That might not be so bad after all. So don't be discouraged if you don't think that you've fully completed the challenge, right? still submit, you know, and you put in a lot of effort in it. So still submit what you've had and before the deadline, and submit the CAD file as well as the written documentation. Okay. And that's all I have. I think we are good on time. I want to ask any of the other organizers if they have anything else they want to share.
Good for now.
No? Okay, so I think that'll be all for the first webinar. The next webinar will be October 8th, and we will talk about the past competitions and go through live. And we've invited one of the past participants to help us with that. So thank you so much.